Hello everyone, my name is Paulo Santos. I am PhD student in University of Beira, Guelma, Portugal. The title of this work is Impact Characterization of Bio-based Sandwich Panels with Cork core and was a collaboration between myself and my colleagues Bouhemame, Paulo Reis and Bezazi. This work is divided in 6 sections. The first is the motivation and objectives. Second is the materials used in this work. Third is the materials manufactured. Fourth is the experimental procedure. Fifth is the discussion of results. And the last is the conclusions. Why this work? Manufacture a natural-based material using natural elements. Exploit the interesting mechanical and physical properties of the cork. Chemical, natural, lightweight, compressible, resilient, shock absorbent, stable, moisture-proof, flexible to benefit the mechanical properties of composites. Literature reports benefits in terms of impact strength when cork layers are added to the laminates. In this context, the aim of this work is study the low-velocity impact response of the two different laminate composites. In this work, the materials used was epoxy resin, green epoxy 15.5 and respective hardener, both supplied by CEMMPRE, left palm rushes and cork. Two types of laminates were manufactured, one consisting of 4 layers of left palm rushes arranged in different directions, as shown in the figure, and one also with 2 layers of left palm rushes, 1 layer of cork and 2 more layers of left palm rushes. The manufacture laminates consists in 4 steps. Step 1. Resin preparation with hardener and alignment of left palm rushes and cork. Step 2. The system 4 layers of left palm rushes plus cork plus epoxy resin was produced by wet layup technique at room temperature and after was placed inside a vacuum bag during 24 hours. Step 3. The post-cure was followed according to manufacture datasheet in a oven at 14 degrees during 24 hours. Finally, the samples were cut with the appropriate dimensions to the respective mechanical tests. Low-velocity impact tests were performed using a drop weight testing machine, Imatec IM10, impactor diameter of 20 mm with mass of 3 kg approach as used. The tests were performed on square section samples 75 per 75 mm and the impactor stroke at the center of the samples obtained by centrally supporting the 100 per 100 mm specimens. The impact energy used in the tests were 1, 2 and 3 joules. Impact tests carried out at room temperature and according to the procedure described in the standard ISO 6603. The first pictures show the front and back face of damaged laminate with 1 joule impact energy. Impact tests were carried out considering as variables not only the material of the sample but also the impact energy. The figure shows the energy versus time, load versus time, and load versus displacement curves for laminates. These diagrams represent a typical behavior occurred for all laminates. Impact tests were carried out at different incident impact energy levels, mainly 1, 2, and 3 joules. The figures show the load and energy versus time response of laminate and laminate plus cork, respectively. For these three energies, these curves represent the typical behavior of each laminates and are in good alignment in the bibliography. According to the figure, the value of maximum load is very dependent of the impact energy. Some authors found that the maximum load increases with increasing impact energy, and similar tendency was observed in this work for both materials, as shown in figure. The figure compares the elastic recovery for each laminate. The elastic energy was calculated as the difference between the absorbed energy and the energy at peak load. The figure shows the energy profile diagrams of the laminates considered in this study. The data points of each laminate are close and all of them below of the equal curve. The absorbed energy never equals the impact energy. Then the penetration hole has not reached it. The data plotted in the figure can be fitting for the H laminate type by the equation exposed, where delta E is the energy absorbed, E0 is the impact energy, and alpha, beta, and gamma constants present in the table. The figure shows the penetration dissolve for all laminates, and values of 3.1 joules and 3.6 joules were found, respectively, for laminate and laminate plus cork. Conclusions. Regardless of the type of materials, understanding the maximum average impact force increases with impact energy. The average displacement increases with the impact energy on the two materials under study. In terms of absorbed energy, we found that the application of cork in laminates is beneficial. In terms of absorbed energy, we find that the application of cork is beneficial. Thank you for your attention.